Okay, so hi and welcome everyone. Can you hear me? Hello.
Yeah.
Okay.
Yes, we can.
Okay, thank you. Okay. Okay, so now we will start our today's session. So mainly today's class I will show you that how we can easily use the machine learning in Google Earth Engine platform and make the land use land cover classification one by one, all of this process. I will try to show you that. So let's simply share my screen.
Your voice is not clear.
Okay, so now it's clear. Can you hear me properly? Okay, so now
Yeah, we can, but there's a lot of traffic noise.
I think some is okay. So let me check. Just a minute. Okay, so now I hope it will be okay. So can you see my screen now?
Yeah, no, it's okay.
Okay. So basically today is our sixth number of day. So basically today I discuss about that introduction to machine learning in Google Earth Engine platform. Then how we can easily use the supervised and unsupervised algorithm to make the land use and land cover classification, as well as how we can easily apply the random forest, then classification regression trees, support vector machine, minimum distance classifier to make the land use land cover classification, and how to check the land use land cover accuracy assessment using the Google Earth Engine. So mainly overall accuracy, kappa accuracy, producer accuracy, consumer accuracy. So this type of accuracy, how we can easily calculate it. We will try to discuss about that and calculate the land use land cover class area. So how much bill of area, how much vegetation, how much barrel land is available for a specific land use land cover classes. We just have to calculate the area. Then how to add the legend in a level C map, and finally how to export land use land cover map and make the research paper map using the art map software. Okay, so let's go. I will simply share my screen. Hello everyone, welcome to the Study Hacks Institute of GIS and Remote Sensing. So first of all, I will give an announcement for our upcoming online training program on Google Earth Engine. So basically, this is the totally beginners online training program. In this online training program, you will learn all of those things which you need to Google Earth Engine for remote sensing analysis. So basically, in this online training program, we are focused non-coder or who don't have any knowledge about the coding. In this time, you can learn all of those coding, all of those programming, and then you also try to able to implement this type of programming knowledge to use the Google Earth Engine for remote sensing analysis. And our upcoming online training program will be start on the 8th December, and admission last is the 6th December. And first 10 registered people will get the 50% discount on this online training program. And here the total 7 class, mainly Friday and Saturday we take the class, and class duration mainly 3 hours. And we are take the class for the this time period GMT plus 6. And mainly if you want to join this online training program, you learned all of those things which you need to start the using Google Earth Engine platform for remote sensing analysis. And we also try to cover for the land use land cover classification using the different types of machine learning method, mainly supervised and unsupervised. We also try to discuss about the NDVI change detection. We also try to discuss about the time series analysis, calculating any indices. We also talk about the air quality monitoring. So all of those things we try to complete it. And it's very important thing is that you can start all of those things from the stress. And here you can see the course content about that. So all of those course content for the first day, what you learned, second day, what you learned, third day, what you learned, fourth day, fifth day, sixth day, and seventh day, what you learned. All of those things I added in my video description. You can simply check it. As well as you can also get the benefits such as course certificate after submitting all assignment. You can get the material slide PDF. You can get the practice code for all. You can get the recorded class. You can also get the lifetime teaching support. It's very important. So when you want to learn first time in Google Earth Engine platform, you face a lot of problem. So that's why you need the continuous support for your learning in Google Earth Engine platform. So that's why when you join this online training program, you can get the lifetime teaching support regarding any issue in Google Earth Engine platform. And this is very important for learning the Google Earth Engine platform for beginners. If you want to join this online training program, you can simply contact in this WhatsApp number. You can also contact with this email. Then you can get the further details information and booking your seat. After that, you can easily join in our Google Classroom. And from this Google Classroom, you can easily get all of those supported, such as you can easily get all of those practice code, all of those material, all of those recorded video class. So all of those things you can easily access from the Google Classroom. Okay, so if you want to join, then as soon as possible, booking your seat and confirm your registration. Thank you. So first of all, machine learning in Art Engine platform. So in this time, we are easily use the different types of machine learning algorithm, such as supervised, unsupervised, as well as also reinforcement. This type of machine learning we can easily use in Google Earth Engine platform. So mainly machine learning. What is the machine learning? Mainly study in artificial intelligence concerned with the development and study of the statistical algorithm that can effectively and perform tasks without that explain the instruction. So mainly in Google Earth Engine platform, we are use this type of machine learning such as supervised classification, unsupervised classification, and regression. Okay. So first of all, supervised. So mainly supervised classification or supervised machine learning method, you must need the pre-categorized data. Okay, and unsupervised machine learning method, you don't need take any types of pre-categorized data. Okay, so supervised classification method, you must need the pre-categorized data. Mainly, it can be ground truth data. Okay, suppose you take the some ground truth data and then you just make the model and then make the different types of classes. But unsupervised classification model, you don't need to take any types of ground truth data. Okay. For that, we are just use here the unsupervised machine learning method without ground truth data. Just it mainly find out the similarity. Suppose all of those water pixel value have a specific similarity. All of those build-up pixel value have a specific similarity. So mainly unsupervised classification, it find out the similarity and classify different group. But supervised classification, in this time, we are just using the ground truth exam sample or pre-categorized data or ground truth data. We need to input in our model and then make the different types of classes. Okay, and regression. So mainly regression is a classification model. It mainly work for that predict a continuous variable of each point. For example, regression model could predict the water quality, present forest cover, present cloud cover, and crop yield. So these type of things we are using the regression model. So let's go. So in this time, what is classifier? So mainly the classifier, that algorithm which implement in the classification on a data set is known as a classifier. Suppose I have a data set. So now this data set, I just implement a algorithm. It can be supervised or unsupervised. This algorithm called as a classifier. Mainly classifier, there are the two types of classifier we can find out. One is the binary classifier, also multi-class classifier. So suppose you make the classification problem has only two possible outcome. So when you can get only two possible outcome, that it's called the binary classifier. Suppose yes or no, male or female, spam or not spam, cat or dog. Only two outcome. Okay, so it's called the binary classifier. As well as the multi-class classifier. What is multi-class classifier? Multi-class classifier problem has more than two outcome. Okay, so it's called the multi-class classifier. So classification of the types of the crop, classification of types of music, land use, land cover classification. So mainly when I get the result more than two outcomes, and then it's called the multi-class classifier. So binary classifier, it's only for the, and multi-class classifier, we find out the more than two out supervised and supervised, how to make the land use land cover classification chart, land use land cover classification area, and how to add the legend in a land use land cover map. So let's go. So mainly when you want to make the land use land classification map using supervised classification, in this time I talk about the supervised, then talk about that unsupervised. So mainly supervised classification, when you want to make the land use land cover map, we have just need to follow some step. First of all, you selecting your region of interest. Suppose which boundary or which area you want to make the land use land cover classification map. Simply select your boundary. Okay, you can easily import your boundary shape file, or if you want, you can easily import your boundary shape file. Okay, then selecting your region of interest, and then choosing and filtering the image collection. Okay, if you want, you can use at the Landsat, or if you want, you can use at the Sentinel. There is no problem. Okay, just choose and filtering your image collection. After that, collecting the training point. In this time, it's a supervised machine learning model. So for that, you must use the training point or training sample. You must need to collect for develop the supervised algorithm. After that, you need to merge all of those training point and then make a training data set. So basically, this training data set, mainly it's collecting the training sample from the ground truth, collecting the spectral signature of a specific point. Okay, it collected the spectral signature from the band pixel value. Okay, different pixel value, and make the training data set, and then create the classifier. In this time, classifier is that mainly algorithm. Okay, in this time we need to create the algorithm and then classify the image, because already we create the data set. Okay, you can see after making the training data set, this training data set we train using the classifier and classify the image and display the classified image result, and then also print the confusion matrix for accuracy assessment, and then calculate the area for each classes. So in this time, we are just follow this type of step and then try to create the land use land cover classification map. Okay, so let's go. I just simply open my code editor. So, okay, so in this time, first of all, I just simply imported my boundary. Suppose I want to make the land use land cover classification map for the, suppose, Dhaka city. I simply import the Dhaka city boundary and give the variable name, suppose RY. Okay, and now display the result, suppose map dot add layer of this RY, and also center focus. So map dot center object of this RY, suppose zoom level 10, and click run. So now it's focusing my study area. Suppose this is my study area, and now I want to make this study area for making the just making about that land use land cover classification map. Okay, So for that, in this time, I need to choose and filtering the image collection. Okay. Suppose in this time, I just use the image collection for suppose Landscape image I use. So I simply click on the Landscape image collection. And then suppose I am using the Landscape 8 image collection. So simply click on the Landscape 8 image collection. And then suppose in this time we use the surface reflectance image collection. So I just simply copy this image collection. So in this time I just choose Landscape image collection and then filter the image collection for my study area for the specific time period. Okay. So just take a variable. We already discussed about this part. And before that, simply paste here and give a variable name. Suppose I put the variable name is hey. Okay, you can put any variable name. So now just filter. So take a variable image. So just I filter my image collection. With my study area. And then also filter and choose the cloud cover. Function and put the stems of year of 2020. Suppose 1st January from year of 2020 December, suppose 31. Okay, and then create the median composite and then finally click with my study area. Okay, so in this time I use the median composite. If you want, you can also use the single date image, no problem. Same approach. So now in this time I just simply show the layer. So just use the map.add layer function and show this image click to the run. So now it will be stirred. So now I simply click on here and set the band combination. Suppose red band, green band, and blue band. On natural color composite, I simply set and apply. Apply. So now I can get this type of images, satellite images. Okay. So now this satellite images, I just need to classification using the machine learning model. So I will complete my first step and second step, selecting the ROI and also choosing and filtering the image collection. Okay. So now move to the third step, collecting the training point because it's a supervised classification model. Okay. So supervised classification model, we have to use the training sample. Okay. For collecting the training sample, we have just make this create the spectral signature. So in this time, for suppose in this time we are using the different types of band combination. You can see it is the red, green, and blue. When I use the red, green, and blue, then I can get this type of visualization. Okay. So suppose when I use this type of band combination, suppose near infrared, red, suppose blue, apply. So now type of visualization you can see. Okay. So in this time you can see I can get the water body as this type of black color. Okay, all time. Suppose you use this type of band combination near infrared, red and blue, then we can get the water body this type of color. Okay, black color or dark color. When and as well as we can get the vegetation as a red color. Okay, vegetation we can get as a red color. So this is another band combination we are also used for the identify the water body and vegetation, as well as you can see the another band combination such as short wave infrared one, then near infrared, and put here green. Okay, so it's another band combination. So mainly when you use this type of band combination, we can easily identify the barren land as well as also vegetation, You can see, okay, this type of green color, or is there the cube and then about plus 28%, right? You can also easily identify the, you can see this type of land is the barren land. Okay. Also, you can get the wetland, this type of wetland, identify about the wetland, this type of color, and this type of identify about the barren land or fallow land about that. Okay, and we can get the this type of things. We can get the vegetation or cropland. Okay, this type of things you can see. Mainly, we can get this type of light green color. Light green can identify about the cropland or agricultural land, and dark green color. This type of dark green color identify about that vegetation. Okay, and this type of light green color pixel will identify about that agriculture. So this type of things you can easily get the from this link. So I simply show you that. Suppose Lancet Lancet 8 then combination. So here you can get the lot of information about that. How what's the band combination? What type of feature we can easily get from here? You can see. You can see this is the natural color. Okay, 432 mainly red, green, and blue. Okay, so mainly when you use the red, green, and blue, then we can easily get the healthy this type of feature. Okay, and here we can get the natural color composite. Use the band combination red, green, and blue. It replicates the close to what our human eyes can see. Okay, healthy vegetation is the green, unhealthy flora is the brown, urban feature appear in the white color, urban feature at gray, and water is the dark blue or black. As well as this is another band combination, near infrared, red and green. So I can get this type of feature. In this type of red color identify about that vegetation. Okay, water dark areas are water, urban areas as a white are white. Okay, as well as also you can see this another band combination about the short wave infrared, as well as also you can see the agriculture. So 652 short wave infrared one, near infrared, and blue. So mainly you can get this type of feature show as a barren land or fallow land, and this type of feature show as a agricultural land. Okay, agricultural land. When I use this type of band combination, as well as you can see the geology. When you want to put this type of band combination, then it try to find out the identify the geological formation or lithology feature or fault. We can easily identify when you want to use this type of band combination. Also into the bathymetric, we are using this type of band combination for identify for the bathymetric and aerosol studies because it reflected the blues and violet. We can easily use this type of band combination. Okay, so mainly we are using the different types of band combination to identify the different types of feature. Okay, and collect the training point. Okay, suppose in this time I collect the training point. Suppose water. So how I can collect the training point? So just I simply click on here. You can see the marker, and also you can see the geometry. Okay, when I click on the marker, it added the geometry. So click on here the geometry, and I put the name. You can put any name. Suppose I put the name is that water. Okay, and feature collection. I simply put the feature as a suppose class, and set the property for 0. Okay, I set the value 0. So now click to the OK. You can see it will be added the water, and now I simply click on the water body because the dark area is the water. I simply call the training point for the water body. Take the training sample for the water body. Mainly it create the spectral signature of the water body. So just I simply take this type of, you can see this type of color dark area identify about the water body. I simply collect the training sample for water body from here. suppose then I take the training point for vegetation. So click on the new layer and then click on here again. I put this suppose vegetation. Okay, and then feature collection. Set the property for and value for 1. Okay, so all of the vegetation we consider as a 1. Value is the 1. So in this time, I just simply make the trees and cropland as the same class. So just I simply take the training point for the cropland and also trees and the same class. If you want, you can also differentiate it. No problem. Okay. Suppose you make the classified the cropland and vegetation different two class, then you can take the two time training point. One time for the vegetation, another time for cropland. So in this time, I consider vegetation and cropland as a cropland and and vegetation and trees. All of those other trees considered as a vegetation. Include all of those things in a vegetation. So just simply take this green pixel value and take the training point from here. For barrel length. So simply click on here. So import feature collection property name all time same. Okay, just put here the class and set the value for suppose 2. So okay. So now I simply take the barrel length, this type of land. And in this time I just simply take the barrel land and wetland as a same class. Okay. So I don't differentiate it. Okay. After that, suppose I take the training point for the build up area. So click on here again. And then suppose I put here that build up and take the feature collection and put here the class and put here the tree. Okay. So in this time 0, 1, 2, 3. Okay. So now you can see build up area, select the build up area, select the build up area and take the training from build up. So in this time you get the natural color. So and then apply. And when you mistake any, suppose in this time again I put this in here, a marker in here. So just simply click on here, exit, and then click on this marker, and you can see delete option. Click the delete. So then it will be removed. So now in this time, simply select on these things from here, and now take this training point for the build up. So this is the build up area. So that is it. So in this time, you can see I take my training sample. Suppose water body, vegetation, barrier and build up. So I complete my third step. Okay. So our third step is that correcting the training point. Okay. And now fourth step is the merging all of the training point. Okay. So now how I can merge? For the merging, we just simply take a variable and all of those training sample we are merged in here. Yes. Yeah, please. Okay, so mainly feature and feature class. So in this time here you can see the feature is only for the without label. Okay, feature is without label. But when I define it feature class has a label about that. Okay, suppose you can see the mainly the feature collection. Feature mainly feature is the for the single. Okay, and feature collection mainly is the combination of the more feature. Okay, more than one feature combination is the collection. And class you can also say that what is the feature, and feature class is labeled. Okay, it's the label, so I put the label. Suppose in this time you can see for the feature collection class all of this build up area class I set the label for 3. So in this time here you can say I can take the total build up. Okay. So all of those 38 training sample for build up area, and what is the level? Okay. Because I set the value for. Okay. So now I just need to merge. Just I need to merge all of those training sample at the same time. So for the how you can see it. So in this time I need to merge. So how I can merge? Just take a variable. Suppose I put the variable name is that suppose sample, and merge all of the training samples such as water. It merge with vegetation, merge with Ireland, merge with love. Okay, so in this time I simply merge all of those things together and store it in this variable. So now you want to check, simply use at the print function and then check it about this result. In this time it show the result how much training sample you take. Okay, for the all of those classes. So I run the code. In this time you can see it shows the feature collection. Here I use total 132 training sample or training point. So now in this time click on here. Here you can see the list about that, and all of this training sample has the pre-categorized data. Okay, or level. You can see suppose this 10. You can see what is the level. This level is that 0. Okay. Suppose you check the another training point. Suppose this training point, what is the level? This level you can see this level is the 1. Okay. And what is the 1? 1 is that vegetation. You can see 1 is the vegetation. We already declared about the 1 is the vegetation. So all of this training sample now it including their level or pre-categorized 0, 1, 2, 3. 0 for water, 1 for vegetation, 2 for barren land, 3 for build up area. So all of those training sample we pre-categorize. Okay, you can see pre-categorize. So this it's 3. Okay, so this training point I collect the information for barren land. Okay, because you can see the build up because you can see this is the value is the 3 for build up. Okay, so in this time we are get the class all of those class level. So 0, 1, 2, 3. Okay. So in this time, I need to extract the band pixel value from all of the training points. I extract the band pixel value. This training point, I extract the band pixel value. This training point, I extract the band pixel value. So total, all of the training sample, 132. Okay, total sample. In this time, I extract the band pixel value. Okay, and in this time, which band I use to create the spectral signature of each training point, I need to define it. So for that, I just take a variable, suppose bands, and then make the list all of those bands which I use to and make the spectral signature. So how I can do that? First of all, you can check it, your satellite image, you can see. So mainly here you can get the SRB1, SRB2, SRB3, SRB4, SRB5, SRB6, SRB7. Suppose in this time I use here all of those bands, SRB1 to SRB7. So in this time I simply make the list about all of those bands. So SR1, then SRB2, suppose SRB3, SRB4, SRB5, or SRB6, SRB7. In this time, for each point, suppose this is my point, this point, I extract all of those band pixel value only for this point. So in this time, all of those points, mainly here we can 132 points. Okay, so for 132 points, all of those bands values we extract and create a data set. So this is my data set. So further I use this data set and make the classification. So now how we can easily extract? For extracting the band pixel value, we use the function reduce sample. Okay, in this time we talk about this step. You can see in this time we make a training data set by sample region. Okay, we use the sample regions function to make the training data set. So mainly it is the extract the band pixel value for each point. Okay, extract the band pixel value for each point. So just take a variable, suppose training, and first of all I need to call the image. Okay, so I simply call my image. I already create the image. You can see I already make the image. So this is my image. Simply copy, and from this image I just choose all of those bands. All of those bands I choose. So simply use the select function, select and choose all of those bands. Simply copy the variable and paste here. All of those bands, and then use the function sample regions. Okay, so in this time, this sample regions, this function extract the band point. Okay, extract the band pixel value for each point, which I add all of those band pixel value extract for each point. So just use the and then put all of those argument one by one. So just I make a dictionary. So curly bracket start and also curly bracket in. So now first of all collection. So what is the collection? Collection mainly total 130, okay? And it is stored in this variable sample. Simply copy the sample and paste here. Now properties. What is the properties? Properties means I set the property for all of these classes. Property name is the class. Okay, so property is the class. In this time, it show the properties. It's a plural form, not singular. So for that, I need to use here the square bracket and put here the this things class property name. Scale the resolution of your satellite images, 30-meter resolution. And then I simply remove from here. It's not need from this time. And now I simply print that thing. So simply print from here. And then print this training, simply copy and paste and click to run. So now it is extracting all of those band pixel value for each point. Here you can see the feature. So all of those training points, suppose click this training point, here you can see it extract the band pixel value, all of those SRB1, all of those band pixel value extracting from here. And what is the class? Class mainly 0. 0 means the water. So all of those training sample extract the band pixel value from here. data set. Okay, so this is my data set. So now I use this data set and train my model using the machine learning. Okay, and machine learning is the that we have to use the some data for train our model, and also need to use the some data for test our model. Okay, so in this time here I can get all of those data set. Okay, so this is my data set, this variable is stored my full data set. So now according to the machine data set, suppose here I use the 80% data, 80% data for train my model, and also use suppose 20% data for checking the model, or uh, model I use, or testing this model. Okay, so in this time 80% data I use for train my model, and 20% data for check my model validation or testing this model, what is the accuracy about this model. So this is the basic concept about the machine learning step. This data set we need to split in two way. One is the 80%. Some people also use the 70% or 30%, 80%, 20%, or 60%, 40%. No problem. So you can use at this type of ratio. Just you can split some data set use train your model, and some data set for checking your model, for testing your model. What is the accuracy about that? So and this training data set we need to distribute randomly. Okay, suppose I take the randomly 80% and also randomly 20%, randomly. So for that, in this time, this full data set I need to convert into random distribution. Okay, so how I can do for the random distribution? For that, just take a variable. Suppose I put the variable name is that data set, and full data set is stored in this variable, but in this time I need to randomly distribution. So for that, paste in here this variable and use the function random column. Okay, so basically this data set distribute the data set randomly and store it in this variable data set. Okay, so now this data set I split into 80% and 20%. So how I can split? So for that I simply take a variable. Suppose I put the variable name is the train set. I call the data set full data set. From this full data set I just simply use the filter engine greater than random 0.8, as well as also take the test set, another variable at the call the data set, and use the filter filter less than equal random 0.8. So in this time it's filled into 80% data greater than and less than 80% data, which means the 20% or 20% about this. So in this time we simply split the train set, test set. So this train set I use for train my model, and this test set I use for checking the model validation and testing this model. Okay, so now I need to train the model. For training the model, okay, so in this time there are a lot of classifier is already available in Google Earth Engine platform, such as random forest classification and regression trace, minimum distance. So there are a lot of algorithm is already available. So mainly in Google Earth Engine platform, we are using the built-in algorithm. Okay, suppose you can see this type of algorithm already built in, such as I simply search here, suppose classifier So here you can say I already get this type of algorithm. Okay, and this algorithm is the built-in, already available. This type of algorithm, just I simply set with my data set, it automatically classified. Okay, so basically in this time you can see this type of algorithm, minimum distance, classification trees, also support vector machine, random forest. So this type of algorithm has a lot of statistical background. Okay, but in this time it's just built in Google Earth Engine platform. So that's why we are just a function, this type of function we are used and apply the random forest easily. We don't need to put any type of equation. So just we can simply use this function as a random forest. We are just using at the minimum distance as a function. We are using at the classification and distribution trees as a function. Not put any type of equation, not put any types of other things. Mainly when you want to work for the Python machine learning using supervised, unsupervised, we need to different types of equation we need to put in here. But in this time, we are not doing that because Google Earth Engine totally provide the built-in function. And this built-in function, we are easily set and make the classification. Okay, so let's give an example. Suppose in this time I use this classifier. So basically here you can see Earth Engine classifier, random forest. Here we can get the some number of trees. Mainly it's the decision trees. Also you can see the mean leaf population, back fraction, max node, seed. So basically in this time, for the small random forest, this function number of trees we must be used in. Okay? And what is the best number of trees for your study area? We don't know. Suppose for my study area, what is the best number of trees? I don't know. So this number of trees I need to identify. I need to calculate it. So this thing is called the hyperparameter tuning. Okay. For hyperparameter tuning, things I also discovered the previous class also talked about that hyperparameter tuning. So in this time, I simply show you that. Suppose I simply copy it. I simply copy this algorithm and paste in my model. So in this time I create the model. So just take a variable. Suppose I put the variable name is that model. And suppose I put this name is the model. And then paste here. So here you can see this is my function. Okay, random forest. Okay, and I simply remove all of those argument. I add the letter. So this is my classifier. Okay, I use this classifier and train my train function. Okay, and train 80% data. So just I simply make a dictionary and put all of those things one by one. Yeah. Here is the feature. Copy and paste. Then class property. So mainly class property is the, you can see I already provide the property name class. Okay, it is the class property name. Right? And then paste here. In this time you can see it is the property. Use the square bracket. Simply put here the class. But you can see when I use function, when you can get the any argument have a polar form, then we have must use here the square bracket. Okay, but here you can see I can get this singular form property. So just simply use here the class. Don't use here the square bracket. So input properties. In this time here you can see the properties already have the plural form. So that's why we have to use that this type of square bracket. You can see I already use the square bracket. Okay, I already use the square bracket in here and store it in this variable. So I simply copy the variable name. In this variable, store it the full things and then paste here. Okay, paste. Then it's not I simply move that. Now this is my model I created. Okay? And now this model I use for the two purpose. One purpose is that I just classify this image as well as also check my accuracy using this model. So this model I use for classification for this image. So how I can do that? Suppose I suppose LULC and then call my image. So image. I already this is my image. You can see this is my image. I simply copy this variable and paste here, and then use here the select and select all of those bands which I used in here. So this is my bands. Simply copy and paste, and then use the function classify function. Okay, so mainly this function connect my model with my image. Simply copy this variable name model and paste. So now it create the classified map. I simply show the layer. Suppose map.add layer is LULC. Click to the run. In this time I can got a error. You can see it's showing that you must use at the number of trees. Okay, it must use, without it not work. And I don't know what is the best number of trees, or what is the when I use the number of trees when I can get the better map. Okay, in this time I randomly put here the suppose 150. Okay, but this number of trees, what is the best number of trees for this model, we can also calculate it. Okay, then we can put this number of trees in this here, then we can get the better accuracy and also get the better map. So in this time I randomly put the 150 for checking the result. So click the run. In this time we can get this type of layer because we did not add the visualization. So now set the visualization. So just I make it the suppose curly bracket, put suppose mean. It will start from the 0. You can see water is the 0, and put the max build up area for 3. Okay, and put here the and make the list of color 0. I want to set the water for blue color, then set the vegetation for green color, then set the for barren land as a suppose yellow color, build up area for color. So now check it, click to the one. Now I can get the visualization of this map. In this time we can get this type of map. Here we can classify the water body as a blue color, build up area as a red color, barren land as a yellow color, and vegetation is a green color. Okay. So after creating this type of map, we have need to check about the accuracy. Okay. Suppose in this time I get the low accuracy, then we have also need to some step to increasing the accuracy. Okay. So first of all, you have to check the accuracy about this land use land cover map, and then if we get the not good accuracy, then we have to use the some other approach to improving the accuracy of this land use land cover map. Okay. So let's go. What is the accuracy of this map? We try to check it. accuracy, checking the accuracy, we are using the confusion table. Okay, so mainly confusion matrix table we use for calculating the accuracy for confusion matrix table. So now how I can create the confusion matrix table using this 20% data. Okay, so this is my test set. I want to use this confusion matrix table using this test set. So for that, I just simply take a variable, suppose confusion matrix, and put a function ee dot function matrix, and then call your 20% data. Simply copy and paste and set with model. Okay, so for connecting the model, we use that in this thing we also use that the classify function, because now this data connect with our model, and this is my variable name is the model. Simply copy and paste. After doing that, we have just calculated the error matrix and find out the actual value and predicted value. So mainly actual value, it's mainly we are using at the property name. Property name is mainly class, and predicted value all time use at the classification. Classification. So now it's not.
Hello.
Yeah, please. Yeah, I can hear you.
I got several questions.
Yeah, please.
Uh, First question, when we, uh, okay,
Cannot hear you properly.
can you hear me?
Yeah, now I can hear you.
Okay, when we specify any water body or barren land, so
Yeah.
which one is better for, is it to identify point or polygon?
So it doesn't matter if you want to use the polygon or point. It's mainly depend on the pixel size. Suppose sometime you use the polygon, but it has some limitation. When this pixel across the limit 5,000 element, then it will be not work. Suppose I can take the suppose a polygon for this region as a water body. Suppose this region it extract the pixel value over 5,000, then it show the problem. So that's why it's better to use the point. Then it will be take the small pixel value for the specific point. You can also use at the
Can we
polygon.
mix? Can we mix?
Yeah, yeah, you can also mix it, no problem.
Can we? Okay, okay.
Yeah.
So, second question is, here we can see that there is a good number of kappa,
Yeah.
accuracy, like 86%. And how many points should we take? Like 40 or 50 or 60 point. I have used it for the select division, and for vegetation I have taken more than 300 or 200, and it doesn't show uh, this kind of accuracy. Like I have found like 60% of accuracy, which is not good.
Okay,
So
so in this
is there
time,
any?
what's the class you classified? What type of class? Vegetation and other
Yes,
class.
yes.
So what types of class you classified for the division of select?
Water body, vegetation, barren land, mm, uh, then agriculture. Seven
Yeah.
classes. I have
Okay.
classified into
So
seven classes.
okay. So do you have used any external band like as NDVI, EVI, or SAVI?
No, no.
Okay, so that's the another problem. Yeah. So I will come back to this point. So mainly when you want to classify, suppose agricultural land and vegetation. So mainly agricultural
Yes.
and vegetation, this type of classes, spectral signature almost same. Suppose you want to make the spectral signature for the cropland and vegetation or other
Okay.
forest, we can get that same spectral signature. For that, it reduces the accuracy. So that's why you have also need to learn about another thing is that we have also need to add the more band. Suppose in this time in this model, when I put the band suppose as a NDVI band, okay, then I can get the more distinguish between the cropland and agricultural land or vegetation. Suppose for the NDVI, for the agricultural, I can get the high NDVI. For the natural vegetation, I can get the low NDVI than agricultural land. As well as you can also use at the EVI or enhanced vegetation index. Then you can also get the more distinguish between this type of feature. Also use at the suppose SAVI or soil vegetation index. So this type of external band, when you want to use in your algorithm, then we are also get the better accuracy. So mainly in this time here I use the good accuracy without this type of band because I classify vegetation. In this vegetation, I include the forest, I include the agricultural land, I include the all of those other trees as well as a barren land. So all of those barren land or wetland, I consider as the same class. All of those water body, consider the same class. But when you want to make the more differentiate, suppose agricultural land, crop, then vegetation or forest. So then you have also need to add more index or more indices as a band, and then extract the pixel value for cropland or vegetation. Same approach. Then apply it. So then I hope you can easily get the better accuracy also. And how much training point you can take. Suppose in this time here I use at that water 31, almost I use 31, 32, 38. Basically, it's depend on your study area. When you want to work for the big region, such as whole country boundary of Bangladesh, so actually it's also depend on the accuracy. Suppose in this time, I get the accuracy lower than 80% or 70%. Then I also need to put the training sample for each classes again. So basically, how much training point I take for each classes, it's mainly depend on our accuracy. If I did not get the better accuracy, then I also take the more training sample. You can also take click the satellite map, and you can also compare your land use land cover result from here. Suppose you can simply just decrease these things and then simply zoom in your base map, and you can also choose it is the water body, what is the change about that. This is another way, and also take the training sample. Okay, so mainly how much training sample I can get, it's mainly depend on our accuracy. If I did not get the better accuracy, then I also increase the accuracy. As well as if I did not get the better accuracy for the more classification agricultural and forest or vegetation, then we have also need to add the this type of external bands, NDVI, EVI, SAVI. Then we are also get the more, then our data set also big. Okay, suppose in this time I use only for this type of values. But when I add this type of values, NDVI, EVI, SAVI, or more other values for the vegetation index or barren land, mainly you can see the sometimes barren land and build up area, because barren land and build up area, this spectral signature is the almost same. So that's why it's mixing. It mix each other. Suppose barren land mix with the build up area mix with the barren land. Commonly, it always mix. But when you use here this type of index, suppose you put here the one band for normalized difference build up index, you can use. You can also use here the BI index, barren land index. Then it also make the distinguish between the barren land dataset and also build up area dataset, and then we also get the better accuracy. Okay. Okay, I hope you can got the point, and I also show you that how we can easily add this type of other external band. Okay. So any question, please, in this time? Any question?
I got
Yeah.
another question.
Please.
In configuration matrix, for feature classes, in feature class, when we use zero, like we have used water as zero,
Yeah.
uh, can you click it say, on the settings point?
So in this time,
Here we
it
can
not
see that
showing in here. I think some there are
yes,
technical
yes.
issue about that, but it still count as a zero. No problem
Okay,
about
okay,
that.
okay.
Okay.
And we have seen that for predicted, like we have used classification, but uh, I am a little bit confused about that point. And predicted,
Okay, okay,
why?
okay, okay. So in this time, actual value comes from our property, and mainly this is the set about this model. Suppose when I use this type of model, mainly machine learning model we are used for the classification and regression. Okay, so in this time, I want to predict the classification using this model. So that's why commonly all time we are using the classification, predicted the classification using this model. And every classification model provides the two things, classification and regression. So in this time I use the classification. So that's why I put the predicate value as the classification. Okay.
Okay, thank you.
So now talk about the binary classification of the problem. So it's very important about the binary classification because binary classification we can get only for the two class. Suppose you want to classify the only for the two class, then we have to choose our algorithm. Which algorithm is better for the binary classification? So mainly binary classification for the better is that support vector machine classifier. You can see the support vector machine algorithm. I simply show you that. Suppose support vector machine. Support vector machine algorithm. Basically, this algorithm is very perfect when you want to classification only for the two classes. Suppose you want to identify for that forest and deforestation, then we can easily use here the support vector machine, because you can see this type of example. Suppose you can see this type of example here. You can see this type of pixel value. Suppose you can see this is the vegetation, this is the water. Okay, and mainly support vector machine always try to create the best decision trees about this type of decision boundary. Best decision boundary create is the main target about that, and classification, and also calculate distance from the baseline. So in this time, when you want to make the only for the two class, suppose forest and deforestation. I will show you the example. It's so better. I already make the code about that. Just a minute. For the support vector machine, mainly binary class we are using the support vector machine. When you want to make the forest and deforestation region, then you can get the better accuracy. Okay, and mainly when you want to work for that more than two class, such as in this time water, vegetation, barrel and build up area, then it's also better to use the random forest, as well as you can also use the classification and regression trees. Then you are also get the better result about that. Suppose I show you the example about that support vector machine. And support vector machine, you have to use different types of argument also. Suppose I just click to the run and show you the result about that. In this time here you can see it just take the training sample as a polygon. If you want, you can also use the polygon. There is no problem. But sometimes we can get the problem such as it exceeds the memory limit. Okay. So here you can see mainly it classified the two class, deforestation and forest region. And basically in this time, you can see the algorithm about that. So this is the algorithm that used at that support vector machine, SVM. And support vector machine mainly a radial basis function, okay, RBF. In kernel type mainly it's identify about that is the different type kernel, support single kernel type. Also you can see in this time they are used at the RBF mainly radial basis function. And gamma, so gamma we can get the two types of gamma. One gamma is the high gamma and low gamma. And also cost function, cost mainly is the identify about the angle. So it's a lot of statistical lecture about that. But in this time mainly in Google Earth Engine platform we are using the support vector machine, and radial basis function is very popular kernel type for making the binary classification. So use at the RBF. And gamma mainly, what is the gamma? Gamma mainly high gamma and low gamma. We can get the two type of gamma. So when we can get the distance, suppose this distance from the basically this type of pixel or this type of point called the support vector. Okay, when the distance from the decision boundary is the high, then we can get the low gamma. And when this decision boundary to the support, this distance is the low, then we can get the high gamma. Okay, so this gamma, and this time they are using the gamma distance 0.5. And then cost, so it's the cost function, they are put here the cost value 10. So this is the algorithm, same approach. Then simply train this model using this algorithm and classified this type of class for deforestation and forest region. So it is a binary class. So all types of binary class, when you want to classify, just use the support vector machine. Then we can get the better accuracy as well also get the better land use land cover map. Okay. So it is a support vector machine. Yeah, okay, I also send you this code also, no problem. You also try to check and also try to practice for the other region to make the support vector machine for the binary classifier. Okay, so any question? Okay, so how to obtain training points? Studified the method for existing land cover map. Okay, so you have already, okay, so suppose you can already added a new, okay, so just let's check the, so existing, and what type of land cover data set you want to add in here? Suppose it is any kind of, suppose modis land use land cover data, or what is the base for your sampling data you use? In this time we are also get the, suppose you can easily get the sampling, suppose existing land cover map also. Okay, suppose you can see the example. In this time there it's an image, it's not like that. Suppose random forest. Okay, so basically in this project we are used at that training sample data for our previous ready-made land use land cover data set. I think it's what for the E3 land use land cover data set used as a okay. So let me find out this practice code. Where is it? Okay, so let me check. Oh, just a minute. I discuss about this topic again. Very important topic for that. How we can easily use the base map or other data set. Suppose in this time I use here that suppose E3 land cover data set as a level source classifier in training. Suppose I just simply call the data set E3. Okay, 10-meter resolution. Yeah, this data set you can see. In this time, I use this data set and it's classified. You can see over 10-meter. Yeah. Yeah. So this data set you can see, and it classified. You can see the tree cover, shrubland, grassland, cropland, build-up area, where and sauna and ice. Okay, this type of class is classified. So just simply import that. I put the name suppose so that take put the name suppose LULC. So now display the result. So map dot add there and call the LULC. Click the run. It's a global data, so you can get this type of color. You can see. Okay, with that color we can get this type of result that had the color from here. Suppose you can see this type of color. So, and you can see this the value is that 10, 20, 30, 40, this type of value already using here. Okay, so I did not use this. Suppose in this time I use this type of class as a base and then classified any satellite images. So for that, here I also need another thing. Suppose from here I just simply use the Dhaka city boundary. For that I simply import the Dhaka city boundary. Dhaka city boundary. The boundary and put this name suppose ry. Okay, so just app dot enter enter object of ry. Thank you for that. So I get my study area. So now using this study area I use this sample and then work with that. So for that I also need a satellite image. So I use the same satellite image. Suppose if I use it here, so median image collection. So just I simply copy from here, copy this image, paste. Then I also add this image. So in this time, first step, we need to the import the Landsat image collection also. So okay, just copy from here the Landsat 8 image collection. Landsat 8 image collection. Paste. So now it will work. So in this time, I just need to remap the land cover class value to zero based sequentially series. Okay. So first of all, I just take a variable. Just take a variable about that class values. Okay, and make a list about that. So in this time, we already get the list about that. You can see this is the this data should already make the class such as 10, 20, 30. Okay, I simply put in here all of those class. Suppose 10, 20, 30, 40, then 50, 60, 70, 80, 90, and check what is the class. And 100. Okay, so we take all of this. So 95, 95, 95, and 100. Okay, so this is my class value. So now this class value, I need to remap the values. So 0 to 10. Okay, so 1, 2, 3, 4, 5, 6, 7. Okay, 0 to 10 means 11. Okay, so 0 is also count from 1. Start the counting from 1. So now in this time, I just take a variable, suppose remap. Okay. So in this time, these values I simply remap 0 to 10 as a list. So user e dot list sequence. So sequence list sequence and put here 0 to 10, total 11 class. Okay. And then I take a variable. I put the variable name, suppose level. I set the level about this this LULC. Click copy. We stored the this data set. Okay, and then paste here LULC. So then I simply take the another variable. Suppose I put this variable, same variable LULC, and then use here LULC dot remap. Okay, so mainly this remap function we are used to convert, suppose 0 to 10 to 100 to 0 to 10, we can simply convert. So we already make it, so just put it the remap, simply call this class values. And another thing is that in this time you can say I did not use here the var keyword. Why I did not use the var keyword? Because I already defined LULC is a variable. You can see I already defined LULC is a variable and use the var keyword. So that's why second time when I use this name as a variable, then don't need to use the var keyword again. Okay, so done here in this time I simply ignore this part. Okay, so now remap it, class values simply copy and paste, and further remap values 0 to 10 which I already created, so paste here, and I simply rename it. Suppose you can put any name, suppose I put this name is that level, so put here the rename level, so put here the level. So now just doing that, in this time we are just stratified sample. Okay, and Google Earth Engine platform is already available for the stratified sample function. So for that I just take a variable and put the variable name such as I simply call my image, which I already satellite image, mainly the Landsat image. Okay, I simply copy the image, and then I put the variable name such as, okay, I put the variable name, suppose sample, same variable I use, sample, and then call the image, use here the add bands. Okay, add bands. In this time my band is that LULC. Okay, LULC, this variable LULC, and then use a function stratified sample. So use at the stratified uh, here stratified sample, and then put all of those argument one by one. Just I put here, so just put here that curly bracket, and also put here this curly bracket. And first of all, number of trees, how much number of trees I can take for that, extract the sample. I suppose I put the suppose 100. Okay, so all of those classes I take for the suppose 100. Then class band I put the class band as a level, simply copy the variable name level, paste here. Then region is our boundary shapefile, which is including the extruded the RY. Scale is the resolution. So in this time, this scale is the 10 meter. Okay, this data set mainly this data set ESA world cover data set 10 meter. So and Landsat is a 30 meter. Use here the image. So basically, this image is the Landsat. Okay, so it also better to use the same resolution. Suppose if you want to use here the Sentinel instead of the Landsat, then we can also get the better. Okay, for this, because this data set, this data set ESL and cover data set 10 meter. So if you want to use that the Sentinel, same process also you can also try to apply. Then we can also get the better result. So I put here the suppose 30 for the Landsat, and it's not neat. I should remove that. Sometimes if you want, you can also geometries as a Boolean operator. It's not mandatory. If you want, you can use it just a Boolean operator. And now it's create the sample. So now I check the sample about that. So print the sample. So now my sample is ready. Okay, mainly it's a data set about that. What's the problem? It's showing that okay, so modified loop size. Okay, must be the same size as column name string, the property to the remap. So rename as time we are just here function to check um, required the argument column name missing to the function collection to remap. Okay. This is the class values. We take the class values look like that. Remap values. We make the list about that 0 to 10. Level. I think they're already delivery. Okay, put at the LC only. That's all. In this time, it's MS collection. So LC suppose equal LC dot filter. Okay, we need to convert it as an image. Okay, it's just an image collection. So for that, suppose filter bounds with RY and put here that only for the 1 year data set is available 2020 to 2020. I just take the suppose year of 2020 1st January from the year of 2020 December 31, and I simply create the suppose medium. It is that I put the LLC. Okay, now it worked. Yeah. So okay, so another problem is that if computation is too large. Okay, so it exists the limit about that. But don't worry about that. Okay, we also try to this type of problem you can handle for the other way. So in this time, I just simply shortage my area of interest. Suppose in this time for the Dhaka city, I not use the Dhaka city boundary. Suppose I remove the ROI and take the small area of ROI. Suppose I just show you that. Suppose this is my study area. And give name as a ROI. because it is a very high resolution. Okay, because ESA world cover data set is a high resolution, so that's why it's a lot of pixel value which across the limit. So that's why we need to use a tide scale, or you can also reduction the area to a specific large. And so now click the running check. Now I can get, click on here and see the feature. So here you can see the feature point, click on here, properties, you can see. ID number 46. You can extract all of the pixel value from here, and you can see the LC 0. Okay, so in this time, what is the 0? In this time, we already remap it. So 0 now convert 10, convert into 0. Okay, 10 convert into 0. Okay, then 20 convert into 1, 30 convert into 2, 40, this type of way. So in this time, you can see you can get the 0. So it's our data set you can get. You can see the some also other data set about that. Click on here. Here you can see what is the level about that. LC4. Okay, so what is that? You can see 0, 1, 2, 3, 4. So 50. Okay, so it's a 50. What is the 50? You can easily get it from this data set. Yeah, you already provide the information. What is that 50 about that? And the build up. Okay, now it's created our data set. Okay, so now further you can just apply the same approach. Oh, now your data set is ready. So from here you can just simply use that the suppose 80% data for train your model and 20% data for test your model. Okay, and then classify it using the classifier, and then make this land use land cover classification map, and also check the accuracy. So this is the process how we can easily create. Okay, so I hope you can got your point. Okay, how to obtain the training point using the stratified sampling method from an existing land cover map. Okay, so if you have any question, you can simply write down. So when you can get this type of training data set, after that just apply the same approach which I show you for our this satellite images data set. How you can easily just simply take the 50%, 80%, 20% data set, and all of those things will be same for creation of the map, as well also creating the land use land cover map. All of those things will be same. Okay, so any question? Okay, so it's very easy. Legend is not a much difficult. We just use the code. You can easily get this setup, and you can easily use this technique not only for the ESA land cover data set. All of those existing land cover data set in Google Earth Engine platform, it can be Modis or World Dynamic land cover data set, any kinds of other data set. You can also apply the same approach to make the land use land cover map using the existing land cover map using the stratified sampling method. So I also send you the code. You also try to do that for the other region. So it's very easy. First of all, you can simply import your data set. Basically, first of all, it's not what it's image collection. Okay, so image collection is not a map. Okay, so this image collection I need to convert into image. There's a lot of way to make the convert into image. So in this time, I take the median, get the single image, and store it in this variable LC. Then I simply use my satellite image, suppose Landsat. Then simply just filter the image collection, and then simply just take all of those values. These values I simply convert or remap 0 to 10. Okay, and then simply remap it using the remap function. Okay, and finally just take the sample. I simply image add bands. In this time I use this add bands LC. I use the stratified sample, and I use for the 100 number of points, and then put the class band is the level which I put the LC. Okay, then it's still all of those will be same. Then it created the data set. Further we just simply use the 80%, 20% separate the data, and make that further creation of the land use land cover data set. Okay, Okay, in this time we talk about the prediction. Prediction is not included in our syllabus. Prediction is the further other advanced online training program. Okay, because prediction is the another approach for making this. Okay, so I hope you can got the point about that. So now let's back to our code and try to finish it one by one. Okay. Okay, so now here you can see we make the land use land cover map. So further, sometime you also need to add the band. Suppose you need to add the different types of indices. So how I can add the indices in this map? And in this map, we are just only used for this type of band, SRB1, SRB2. This type of band we are using here. Supposing this time I add the another external band, NDVI. Okay. So first of all, I need to create the NDVI map, NDVI band. Okay. In this time, this image is not created the NDVI band. So I need to create it. And we already discussed about that how we can easily create the band. Very easy. First of all, you can simply take a variable. I put the variable name, suppose so okay. So if there are no question, then I talk about the legend. So how we can easily add the legend on this map? Suppose this map, we already discussed about the one kind of legend. It's called the gradient legend. But in this time, we are just talk about that classified legend. So for the classified legend, we are using a ready-made code. Okay, just change the title or other things. It will be work for any classification land use and cover legend. Just I simply open that. Let's open a new code editor. Before that, we also try to export this map because we also try to make the map. Here you can see when I put at the 100, it reduced the accuracy 89. So I think 150 is the better. And we can also determine this value for the class. Okay. In this time, I randomly put the value look like that. This time 91%. So now I export this map from here. For exporting, just use add the export. I put all of those things one by one. I'll get start and also int. And first of all, image. So what is the image? Image mainly your classified image. So classified image mainly LULC. Simply copy and paste here. Put that description. I put any description. Suppose LULC folder. I put the folder name. Suppose LULC. Region is a shapefile variable name. ROI. Scale is the 30-meter resolution. Not actually of that. Click to run. And then click the tax tab. And LULC, click on here LULC. Run. So now it's exporting. Okay, I can start studying. In the meantime, we talk about the legend. So I open my previous code because short. Okay. So legend. This time I simply run the code. Here you can see it added the legend. Okay, so we are all time for any legend we are use the same code, just something change. Okay, so you can simply copy that. So this code simply copy, and now I want to use this code and add the legend on my this map. So how I can do that? So just I simply paste. Okay, so first of all, nothing to change. Simply you can see title. Okay, so in this time I simply put the title is the LULC or any put, suppose LULC. Okay, I put the title name and also need to change in here. So name and plated. In this time I put the name look like this name. Suppose one is that water, your class name water, then put here that vegetation, and then put here that Berlin, and finally put here the build up. Okay, so in this time I just simply add here the hexa code. Okay, so water for blue color hexa code, green color hexa code, yellow color hexa code, and finally red color hexa code. So here I can get the hexa code. Very easy. Search the Google or just simply open it, and here you can see the sum. Click on here, and you can see it provides the hexa code without hash. Without hash, just simply copy these things. Just simply copy because hash in this time not need. Simply copy and paste here. As well as you can see green. Click the green. So simply copy and paste. Then yellow, it provides the hexa code. You can see simply copy and paste, and finally red color, copy, paste, put the quotation and then paste. So now we can see how many class 1, 2, 3, and 4. Just put here the 4. Okay, how many class? Simply put here the number of the class. So now legend is ready. Click to the run. Okay, you can see LULC, water, vegetation, barrel, and build-up area. So all time, just apply the same approach for create any kind of land use and cover legend or classified legend. Okay, so I hope we can got the point. So any question? Any question or any doubt? Yeah, everything I share, no problem. Okay, so everything will be shared in our Google Classroom. You can easily get from here, no problem. Okay, so any question? Okay, so if there is no question, then our today's session will be in here. And further class we meet for the Friday. I think it's a Friday. We will meet inshallah Friday and try to discuss about that change detection analysis. Okay. So in the meantime, you also try to practice, and further any problem you can ask me the question. Not only for this, after completing the total 7 days online training program, you also get the lifetime teaching support for any time. So when you face any problem, you can join with me Google Meet, or you can also contact in my WhatsApp, and you can easily get the solution about that. Okay, for the lifetime. But for the some advanced topics, suppose when you want to learn the prediction, when you want to learn the suppose any kind of machine learning, deep learning, so then you have to join our online training program. Otherwise, regarding this online training program, total 7 days, for any problem or any issues, you can get the lifetime teaching support. And further, if you want to join our advanced online training program for the future prediction or other types of machine learning, deep learning, okay, then you can also get the lifetime teaching support regarding the advanced online training program also. Okay, so anyone any question or any doubt, you can ask me about that. Any question? Okay, so if there is no question, I will send all of those practice code and also send you the today's decorated video class. You also try to practice, and next Friday inshallah we will meet at the same time and discuss about the further topic. Okay, so thank you for joining. Okay, have a good night.